All right, we're going to look at section 6, 7 today, last section that we're going to cover in chapter 6, graphing linear inequalities. This is on the coordinate plane, not number lines, okay, or not on a number line. Okay, so what we're going to deal with are problems like this. Y is greater than or equal to 2x minus 3. Yes, ma'am. Take these notes. All right. So what form is that written in? Autumn, turn around. Slope-intercept form is what form that's in. That's correct. So the slope is what for this problem? And the y-intercept is -3. So that's what we're going to use to graph these lines, is that slope-intercept form that we learned back in chapters 4 and 5. So we would go to -3 on the y-axis. We'd count up 2 over 1, up 2 over 1, up 2 over 1, rise over run. Okay, and then here's where it gets, the change kind of comes in, where you're not just graphing a line, you're graphing an inequality. So we have to think about whether or not that line should be solid or dotted. And it has the equal to mark. So when we were doing the number line graphs and it had an equal to mark, did we fill in our circle or leave it open? Fill it in. So when we graph the line, it's going to be a filled in line, which is solid. Okay, so equal to mark means solid line. So I'm going to draw a solid line. Oops. Trying to connect all those dots. Okay, but we're not finished. Because it's an inequality, there's more than just those answers. There's answers that are, there's tons of x's and y's that would work for this. Okay, so what we have to do is pick a test point. And the test point that we want to try to use, if possible, is 0, 0. The only time we cannot use 0, 0 is if the line goes through it. Okay, if the y-intercept is 0, then we can't check with that point. So what we're going to do is we're going to plug that ordered pair in for y and x. So it's 0 greater than or equal to -3. Is that true or false? It's true. 0 is greater than -3. Because 2 times 0 cancels out, so we just have 0 is greater than or equal to -3. That's a true statement. 0, 0 is right there. If it's true, we're going to shade the side that 0, 0 is on. So we're going to do some shading here. So I would shade that side of the graph. All of these ordered pairs on this side of that line are answers to that inequality. And because it's equal to, the line is actually included in those answers. And you don't have to shade it very dark, just kind of shade that it's there. Something like doing that with a pencil is good enough. That shows me where it's at. All right. Let's look at another one. Y is less than 2/3 x plus 4. Is that in slope-intercept form? Yes. So that means I can go ahead and graph it. Where's the y-intercept for this one? At 4. So I'm going to go to 4 on the y-axis, put a dot. How do I do my slope? Up 2, right 3. Up 2, right 3. Absolutely. You could go down 2 and left 3. Now, a few dots. You don't need a ton, just a few of them. And then, should this be a dotted or solid line? dotted because it doesn't have what? The equal to mark. So that's going to be a dotted line. So when you connect those, connect with a dotted or dashed line. Now we have to decide whether to shade this side of the line or the bottom side of that line. So we got to pick a test point. We're going to use the origin here, 0, 0, because the line doesn't go through it. And that's an easy one to plug in. That's one of the reasons we're using that. You technically can pick any point that's on one side of the line and plug it in. But we're going to try to use the easiest one, which is 0, 0. So 0 less than 2/3 times 0 plus 4. Is 0 less than 4? Yeah, it is. 0 is less than 4. So we're going to shade the side that 0, 0 is on, which is the bottom side of that. I'm using a highlighter again on the thing here. If you want to use color pencils, highlighters, whatever you want to use there is fine with me. Or if you just want to take your pencil and shade a little bit, that's fine too. Not too difficult, right? Pretty easy so far. Let's look at example C. X plus 2y is greater than or equal to 6. Uh-oh. What's wrong with this one? Non-slope intercept form. So what do I need to do? Subtract the x first to get the y by itself. That's going to give you 2y is greater than or equal to negative x plus 6. And then divide by that 2. So everybody gets divided by 2. The thing you got to watch out for when you're doing this is if I multiply or divide by a negative, what do I have to do? Flip that symbol. So be careful on that. So that's what one of the things that could happen here. Do I flip this one? No. Yeah, because it was a positive 2. So that'd be negative 1/2 x plus 3. And then we can graph that on the number line, on the coordinate plane, not on the number line. We can graph that each side. Where's the y-intercept? 3. So I'm going to go up to 3. Then my slope would be down 1, right 2. I could also go up 1, left 2 if I wanted to. Dotted or solid line? Solid line because it has the equal to mark. Can I use 0, 0 as a test point? Yes, the line doesn't touch it, so I can use that as a test point. So if I plug 0, 0, it doesn't matter which one of these equate or inequalities I plug it into. I'm going to use this one here where we got y by itself because that's the easiest one to compare with. Yes, as long as the line doesn't go through the origin, you can use that. Yeah, we're going to look at one in just a second where we can't use 0, 0 just to get so we can see what to do when that happens. Okay, so 0 greater than or equal to 3. True or false? False. So I'm going to shade away from the origin, which would be this side of that line. The top half of that. Because it was false, I don't shade where the test point was. I shade away from it. Had it been true, I would have shaded the side that the test point was on. All right. Let's look at one. Maybe it's a little bit different. 1/6 y is less than negative x. Is this in slope intercept form? No. So what do we need to do to get it there? Multiply by 6 times 6. That's the reciprocal. So that's going to cancel that out. Do I flip my symbol on this one? No. That's negative 6x. So that's in slope-intercept form because y is by itself. What's the y-intercept on this one? 0. And there's nothing out there. The y-intercept is 0. And that, which is the origin, yeah. So my first dot is there, and then I'm going down 6, right 1, or I could go up 6, left 1. Dotted or solid line? Dotted, because it doesn't have the equal to mark. That's a dotted line. Now here the line goes through the origin, so I cannot use 0, 0 to test. I got to pick another point. It doesn't matter what point it is. You just need to pick one that's on one side of the line. I'm going to pick a nice easy one like 1, 1. Because that's on the right-hand side of that line, right? So if I test it, if it's true, I'm going to shade that side. If it's false, I'm going to shade the other side. So I'm going to test 1, 1. 1 less than negative 6 times 1. Is 1 less than negative 6? No, that's false. So I'm going to shade the left side of that line. Because my test point is on the other side and it was false. You're always going to shade the true side. Always going to shade the true side. Okay. No, we're going to look at a couple of exceptions of the special kind of lines that we could draw that we tend to forget about, but it doesn't get any harder than what we've done so far, honestly. The exceptions are easier, but we just, over the years, I've noticed these are the ones that everybody forgets how to do. Like this one. X is greater than or equal to 4. And we're not graphing that on a number line. We're graphing it on the coordinate plane. Because we just got through doing stuff where you graph that on a number line. We got to graph that on the coordinate plane. Are you done? No, I'm talking Mitchell. He's the one that's got this goofy grin on his face, and he's the one I'm hearing laughing and all that stuff. Okay. All right, so when you graph that on the coordinate plane, what kind of line does it make when it's x and a number? Vertical. So you're going to go to 4 on the x-axis, and it's going to be a vertical line. Anytime it's x and a number, you're going to go to that number on the x-axis, and then it's going to be a vertical line. Should this be a solid or a dotted vertical line? Solid, because it's got the equal to mark. We still have to do shading. Can I test the origin on this one? Yeah, line doesn't go through it, so I don't have a y to plug into. So all I've got to do is plug the 0 in for x. Is 0 greater than or equal to 4? No, it's not. So I'm going to shade away from 0, which would be the right-hand side of that line. What if it's y in a number? Y is less than negative 2. This would be a horizontal line. Go to negative 2 on the y-axis. Should it be solid or dotted? Dotted. No equal to mark. Now it says y's are less than negative 2. 0, is 0 less than negative 2? No, it's greater than, so we'd shade the bottom half of that. Think about it, the y values that are below negative 2 are less than that, so below would mean down. I don't know, so the shading does there. It doesn't get any more complicated than this, or really at all. I mean, this is a fairly easy section. Now we will take this, and next week when we get into chapter 7, we'll be looking at doing a couple of these on the same coordinate plane. So pick it up now, and then when we do 2 of them on the coordinate plane, it's nothing different as far as that goes. It's just 2 at once. On page 409, do 17 through 35. I believe is what I want to do. Make sure. Yeah, 17 through 35. Let's just do the odd ones. That's 1, 2, 3, 4. 10 problems, 10 graphs. You got to draw graphs on these, so it's going to take. So it shouldn't take a ton of room for any of these. They're fairly small. Okay. To C. That one. Page 409, numbers 17 through 35 odd. Let me get this turned off.